Welcome back. This is an Aleks training video on theoretical yield of chemical reactions. Theoretical yield just means what could you produce if you got every single atom or every single molecule of product that you were making out of the glassware. So you mix things in glass and you scrape things out and put it through filter paper, and what could you get if you could get absolutely every single molecule out? What could you possibly produce with a certain amount of stuff? Now, you're never going to get a theoretical yield. It's theoretical because you're always going to trap some in the glass, some's going to be on the stirring rod, some's going to be in the filter paper, some's going to be left over the lab desk, depending on how sloppy you are. But a theoretical yield would be what would be perfect if you could get perfectly do it. And then you have an actual yield of what you can actually produce. So this is very similar to the topic on limiting reactants, where you had to find out how much reactant you had and how much of one reactant you had and how much of the other reactant that you had, and then how much could you actually make. One's going to be a limiting reactant almost all the time. One's going to have an excess all the time. And then you can only make what the limiting reactant allows you to make. Okay, you could have all the peanut butter in the world, but if you only have a few pieces of bread, you can only make a few sandwiches. So you're limited by something. Your theoretical yield, how much can you actually make given the reactants that you're supplied with? All right, so let's see. This says aqueous sulfuric acid reacts with solid sodium hydroxide to produce aqueous sodium sulfate and water. All right, so I've got two reactants producing two products. So I have H2SO4, okay, aqueous, plus NaOH, solid, aqueous Na2SO4, plus water. All right, let's quickly try to balance this. I've got sodium. I've got two sodiums here. Okay. Sulfate and sulfate, I've got 1 and 1. That's good. Let's do oxygens. Okay. I've got, these have already canceled, so I've got 2 of these, so I need 2 of these. That leaves me 4 hydrogens. I've got 2 here and 2 here. All right, so I'm balanced. That's good. So now that it's balanced, I've got 1 to 2 to 1 to 2. All right. So they're asking for how much sodium sulfate. Okay. Sodium sulfate. So this is how much sodium sulfate. Theoretical yield of sodium sulfate, and that means in grams. So remember, you're going to have 2 parts. You're going to first of all find out how many moles can be produced, and then find out for moles how many grams can be produced through the molar mass. Okay. All right, so they're going to give you 2 inputs. They're going to say, first of all, you have 43.2 grams of sulfuric acid. 43.2 grams. Okay, so we're going to find out how many moles that is. And then the other one is 25.7 grams, and we want to find out how many moles that is and go through. Now, we will do it twice and figure out which one's the smaller amount of moles, and we'll put the smaller amount of moles here and then find out how much stuff we can make. All right, so it doesn't matter what order we do it in. Let's do it in this order first. I need to know what the molar mass of hydrogen sulfate is. So I've got hydrogen, I've got 2 times 1.00794. Sulfur, I've got 1 times 32.065. This is from the periodic table. Oxygen, I have 4 times 15.9994. Okay. so 2 times 1.00794 equals 2.01588, and then 1 is 32.065, and 4 times 15.9994, 63.9976. Add those up. I have 98.07848 grams per mole. So I'm going to start with this one. This is 43.2 grams of H2SO4, and it's 98.07848 grams of H2SO4 in 1 mole of H2SO4. Okay, grams will cancel, grams will cancel. How many moles is that? It's going to be 0.44046 moles. Okay, so I'll put that over here. So the H2SO4 will give you 0.44 moles. Okay. Now let's do it again. I need sodium hydroxide. Sodium, I've got 1 at 22.98970. I have 1 at 15.9994 and H1 at 1.00794. Okay, all of those are just ones, so I'm going to add those up. 22.98977 plus 15.9994 plus 1.00794. I have 39.99711 grams per mole. So I'm going to start. I'm going to start here. I have been given 25.7 grams of NaOH. It is 39.99711 grams of NaOH per mole of NaOH. So I'm going to divide that out. I have 0.6425. That means that the NaOH can give me let me rewrite this for you just a minute. Okay. So the first one here, how many moles did I have? I should have written this down. Of the H2SO4, I knew it, how many grams, how many moles, that's what I found. It's 0.44046 moles. How many moles here did I make? It's 0.6425 moles. Okay. Now, I want to know how much of this I can make. So, let's scratch that out. Let's find out what the relationship is. I've got, let's do this one first. Let's do the H2SO4. I've got 1 to 1. Okay. 1 mole is to 1 mole as 0.44 moles is to what? Okay, 1 is to 1 as 0.44 is to 0.44. Okay, so let me write it down here. So for the H2SO4, how much of the ammonium sulfate or the sodium sulfate can I make? I can make 0.44 moles. Okay, that's what I wrote up here, but I'll just write it here. I can make 1 to 1, so I can make 0.44 is to 0.44. Now, what's this? 2 is to 1, right? So 2 moles of sodium hydroxide is to 1 mole of sodium sulfate as 0.6425 moles is to what? All right. So here you're going to have to do the cross multiplying. I want to know 2 is to 1 as what is to what. Now 1 is half of 2, so that x is going to be half of 0.64. So I could just take 64 and divide it by 2, but I'm going to go ahead. 0.64 times 1, which is the same, divided by 2. And I'm going to say that that is, what is this? NaOH. I can make 0.32 0.3213 moles, which is less. Well, I can make 0.44 moles if I use all of this. I can make 0.32 moles if I use all of this. Well, this one's going to be used up first. So it's what I'm going to put here. This is a smaller amount. It's my limited amount, and it's what I'm going to put here. So this is 0.3213 moles of the sodium sulfate. Now I need to go back through the periodic table to find how many grams that's going to be. So I know that this is my limiting reactant. That's what limited it. And now it limited it to this many moles. Now how many grams is that? So I need to find out its molar mass. So sodium, again, is, I need 2 of those, 2.989770. I have a sulfur. I've got 1 sulfur. I've got 4 oxygens. Okay, that's 63.9976. This is 32.065. And now I need to do 22.98977 2. 45.97954 plus 32.065 plus 63.9976, 142.04214 grams per mole. So what do I have? I've got 0.3213 moles of sodium sulfate. It is in 1 mole sodium sulfate. I've got 142.04214 grams of sodium sulfate. Moles cancel. Multiply that out. I get 45.63813 grams of sodium sulfate. Now I need to round it up, so I need to go back and find out what my smaller amounts are. So I've got 3 and 3, so I need to round it to 3. So there's my 3. It's going to be 45.6 grams of sodium sulfate. You're in high school now.